This is part 2 of chapters 1 and 2. We will focus on descriptive statistics in this particular PowerPoint, as well as confidential intervals. So, statistics is about making sense of data, which should consist of one or many groups and involve data sets of virtually any size. So take a look at this particular data set. If someone were to ask you to describe this data set, what would you say? Take a minute and think about it. Would you say something like, it looks like a list of about half women and half men, mostly in their 20s, which would not be wrong, but we can be more precise than that. This list consists of only 50 records and 100 data items, but how would you make a summary statement, a viable summary statement, if the list consisted of 100, 1,000, or even 100,000 records? Such data would span multiple pages, and it would be really hard to inspect. So to better comprehend the nature of a data set, we use descriptive statistics, which is sometimes referred to as summary statistics. Descriptive statistics enable us to concisely understand a data set of any size using a handful of figures and simple graphs that serve to concisely describe the contents of a variable. So these are the various descriptive statistics that we're going to look at, that we're going to discuss in this lecture. We're going to look at number, mean, median, mode, standard deviation, and variance. So the most basic descriptive statistic is number. It's represented as the letter N, the lowercase n, and it's usually italicized. So think of N as the number in a sample. How many participants are in that sample? So good practice. SPSS, now one thing to remember, SPSS output reports always use capital N, but it's good practice when you're writing it to always use lowercase n in your documentation. When you're reading articles, you will always see that lowercase n that's italicized. So going back at this table here, if we think about the number of participants in this data set, lowercase n, it would be 50. So our n is 50 in this table. Now the mean is the average. The average is usually referred to as the mean. And the calculation for the mean is the same as the average. We add up all the elements, we add up all of the numbers, and then divide that amount by the total number of elements. Now median is the middle value of a variable. So think of median in terms of a street. The median is in the middle of the street. It splits the street in half. So to find the median, first you need to arrange the data in the variable from lowest to highest, and then select the middle value or values. So if n is even, then the data set, for instance, here's an example below where our n is 10 and that sample has an even number. Well, then there's going to be two middle numbers, 24 and 25. And so then the median would then be the mean of these two middle numbers. So we would take the average of these two middle numbers. So here's our average right here. So our numbers are 24 and 25, or our two middle numbers. So we're adding them up, which is 49 divided by 2, which would then be our median age of 24.5. When n is odd, well then that makes things just easy because there's just one middle number, and for instance, if our n is 5, in this case, the median would be the middle number, which would be 86. Mode is the most common number in the data set, the number that occurs the most. And for this example right here, our mode is 24. Now, it is possible for a data set to have more than one mode. The example that we have next actually has two modes, 24 and 31. Since both have the most, there are two 24s and two 31s. All of the other numbers just appear once. Such a variable would be referred to as bimodal, meaning that there are two modes. Now, although it's rare, it could be an instance where you have multiple modes, more than two modes, which would be referred as multimodal. Now, one thing to remember, when SPSS detects more than one mode within a variable, it only reports the lowest one and provides a footnote indicating there is more than one mode. And all of these examples are types of measures of central tendency, and they all suggest the center point of the variable. Next, we're going to look at standard deviation. Now, standard deviation is represented, you will see it represented two ways. It can either be represented as a lowercase s or as SD. But basically, a standard deviation represents the average amount of variability in a set of scores. So, in easier terms, it's basically the average distance from the mean. So all of the scores, if you have this set of scores, if you have a set of 50 scores, and you take the mean of that score, for instance, if that mean is 25, you have a mean of 25, well then all of those scores, it's basically the average distance of all of the other scores from that mean of 25. So the larger the standard deviation, the larger the average distance each data point is from the mean of the distribution. Here is the standard deviation formula, where S is the standard deviation. Now we have our symbol for sigma, our sigma symbol, which tells you to find the sum of what follows. Okay? So what follows is our individual score, x, minus the mean of the scores, square, divided by the sample size minus the sample size minus 1. And sorry about that typo there. The mean of the scores, where the symbol is x, there should only be one line above x, not two. So basically, this formula finds the difference between each individual score and the mean, squares each difference, and sums them all together. Then it divides the sum of the size of the sample, minus 1, and takes the square root of the result. So, again, the standard deviation, it's an average deviation from the mean. So let's look at an example here. We're going to go step by step. I'm going to explain step by step exactly how to calculate, how to find the standard deviation. So for instance, if we have a set of 10 scores, first thing we're going to do, we're going to list the scores. It doesn't matter whether the scores are in any particular order, you're just going to list them. And then next, you're going to compute the mean of the group. Find the mean. Then you will subtract the mean from each score. So let's look at our table. So we see right here the first column, X, this is all of the actual scores, and then we calculated a mean of 6. And then in our third column, it shows that we are subtracting that mean from each individual score. So notice some scores are some end up with positive numbers, some end up with negative numbers. So this is what we've done so far, where each individual score minus the mean represents the difference between the actual score and the mean of all the scores, okay, which is 6. Okay, the next thing we're going to do, now we have our differences. Now you're going to square each individual difference, and the results is the column marked, the third column right here, the individual score minus the mean square. And after you square all of those numbers, then you're going to take the sum of that. You're going to add all of them up, and that would give you a total of 28. Okay, so sum all of the square deviations. The total is 28. Now, we're going to divide the sum by n minus 1. Remember, our n is 10, so we subtract 10 minus 1 equals 9. So we have our total 28 divided by 9, which would give us 3.11. So now, don't forget that final step here. Let's see, where is it? Don't forget, we have to find the square root. So let's go back. Now we compute the square root of 3.11, which is 1.76 after we round, and this is now the standard deviation for this set of 10 scores. So what we know from these results is that each score in this distribution differs from the mean by an average of 1.76 points. Now let's take a short step back and examine some of the operations in the standard deviation formula. So let's just look at a few things. Why didn't we just add up the deviations from the mean? Because the sum of the deviations from the mean is always equal to 0. Try it by summing the deviations. Once we sum all of those deviations together, it will equal 0. In fact, that's the best way to actually check whether you've computed the mean correctly. Why do we square the deviations? We want to get rid of the negative sign so that when we do eventually sum them, they don't add up to 0. And finally, why do we eventually end up taking the square root of the entire value in step 7? Because we wanted to return to the same units with which we had originally started. We squared the deviations from the mean in step 4 to get rid of the negative values, and then took the square root of their total in step 7. Now let's look at variance. If you know the standard deviation of a set of scores, and you can square a number, well then you can easily compute the variance of that same set of scores. In other words, it's this, notice this is the exact same formula we saw a few minutes ago, but without that square root bracket. So, if you take the standard deviation and never complete the last step, that last step of taking the square root, you have the variance. In other words, s squared is s times s, or the variance equals the standard deviation times itself, or squared. So remember in our earlier example when the standard deviation was equal to 1.76 before rounding, the variance is equal to 1.762 squared, or 3.11. So let's go back and look. Okay, here is step 7, where it says compute the square root of 3.11. Well, we wouldn't do that. We would just leave it as 3.11, and that would be the variance. Okay. Now let's look at confidence intervals. So a statistic plus or minus a margin of error is called a confidence interval. For example, say the percentage of kids who like baseball is 40%, plus or minus 3.5%. That means the percentage of kids who like baseball is somewhere between 40% minus 3.5%, which would be 36.5%, and 40% plus 3.5%, which would be 43.5%. So the lower end of the interval is your statistic minus the margin of error, and the upper end is your statistic plus the margin of error. So with all confidence intervals, you have a certain amount of confidence in being correct with your sample in the long run. So expressed as a percent, the amount of confidence is called your confidence level. So a confidence level helps you account for the other possible sample results you could have gotten when you're making an estimate of a parameter using the data from only one sample. If you want to account for 95% of the other possible results, your confidence level would be 95%. So what level of confidence is typically used by researchers? I've seen confidence levels ranging from 80% up to 99%. However, the most common confidence interval is 95%. In fact, statisticians have a saying that goes, "Why do statisticians like their jobs?" Because they have to be correct only 95% of their jobs. It's 95% of the time. Sort of catchy, isn't it? And let's see whether forecasters beat that. So let's look at the formula for a confidence interval, where our population standard deviation is known. So you would use this formula here. I am really not sure why there are two lines over the x. I am so sorry about that. But here is the formula. So basically you have your sample mean plus or minus your z-score, which is the z-value from the standard normal distribution for your desired confidence level. And we'll look at that in just a minute. We have our population standard deviation as well as the sample size. So how do we calculate the confidence interval? These are the steps. So first, determine what your confidence level is going to be and find the appropriate z-value. And it looks like I forgot to include it in the PowerPoint. You know what? I am going to include it in Blackboard so you can refer to this table as well. So it's going to be titled Table 13.1. I'm going to place that in the learning module. Okay? So that table basically has the different confidence levels that you can use. Maybe you want to be only at 80% confidence level or 95% confidence level, and then next to it would be a z-score that you would use. So for instance, if you want to have a 95% confidence level, your z-score that you would use would actually be 1.96. Okay? So after you've figured out the appropriate z-value, then find the sample mean for your sample size, Okay? And note that the population standard deviation is assumed to be known. So in this particular situation, you would already be given the population standard deviation. You would not have to figure that out for the population. So then you multiply your z times your population standard deviation. So for instance, if you want to have a 95% confidence level, you would multiply 1.96 times your population standard deviation, and then divide that by the square root of n. And this calculation will give you the margin of error. And then your final step, take your mean plus or minus the margin of error to obtain the confidence interval. So the lower end of the confidence interval is the mean minus the margin of error, and the upper end would be the confidence interval is the mean plus the margin of error. So just like the example at the beginning, so here in this particular example, in this baseball example, 40% would actually be the mean, and then my confidence interval would be 3.5. So I would take 40% minus 3.5 and then 40% plus 3.5, and that would give me my confidence level, my upper end and my lower end. So after you've figured out what your confidence intervals are, so then talk about the results in terms of what the person in the problem is trying to find out in the context of the problem. Talk about it. I want you to interpret it in words that a non-statistician would understand. So for instance, you could say with 95% confidence, the average blank is between blank and blank based on my sample of data. So going back to the baseball example, I could say with 95% confidence, the average percentage of kids who like baseball is somewhere between 36.5% and 40. Sorry, let me say this again. With 95% confidence, the average percent of kids who like baseball is between 36.5% and 43.5% based on my sample of data. Okay. This is the end of the lecture for descriptive statistics and for confidence intervals. And don't forget to look on Blackboard at this week's learning module. The table will be placed in your learning module for confidence levels. Thank you.